Okay, so P12, let's go through this paper then. Question 1. It says, small water waves are created in a ripple tank by a wooden bar. The wooden bar vibrates up and down, hitting the wooden surface. And you can see the waves that have been created there. And it says, which letter shows the amplitude of a water wave? J, K, or L? Well, amplitude is the distance from the base to the height, so it has to be K. Okay, if you look, that's the halfway point there, not J. J is the total displacement. That's the one that most people might have written if they were getting it wrong. L is just nonsense. Okay, so K. Question B. The speed of the wooden bar has changed, so the bar hits the water fewer times each second. What happens to the frequency? Well, the frequency is the number of waves per second, so if it's doing it fewer times per second, then it's decreased. Describe how the wavelength of the water waves in a ripple tank can be measured accurately. Okay, so whenever you get asked how can you measure something, if it's a length, and the word accurately here is important, because if it is a length, you're going to say with a ruler. Now, it's a ripple tank, which means they're not very big, so you're either going to say with a 1 meter ruler or with a 30 centimeter ruler, and it is important that you say how big the ruler is and what units you are using for that ruler. So I'm going to say with a 30 centimeter ruler. And then I wouldn't just measure one wave because they're tiny. It'd be really hard to measure one wave. So what I would do is I would start at a peak and I would measure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 peaks. Okay, for example. Measure the distance for 10 peaks. And then divide by 10. Okay. So, in order to get the first mark on this is after 2 marks, you need to say that you're going to use a ruler, and you need to say how big that ruler is. So you can either say a meter ruler or a 30 centimeter ruler. If you just put ruler, that's not enough. You need to say that you measure the distance for a multiple number of peaks. And you could have picked any number of peaks, but 10 is a good number for this picture here. And then once you've measured the distance for 10 peaks, you then divide it by 10. And that gives you your wavelength. Okay, so that was for the first mark. And that was for the second mark. Part D. It says, the speed of a wave is calculated using the following equation. Wave speed equals frequency times wavelength. The water waves in a ripple tank have a wavelength of 1.2 centimeters and a frequency of 18.5 hertz. How does the speed of these water waves compare to the typical person walking? Okay, so the first thing that I'm going to do is I'm going to work out the speed so that I can compare it to somebody walking first. So that means I need to put my variables into this equation. And whenever I'm doing an equation in physics, the way that I do it is I would say wave speed, which I always label up as c, is what I'm trying to work out, so I put a question mark next to that. Frequency, I'm told, is 18.5 hertz. And wavelength, I'm told, is 1.2 centimeters, which I know is 1.2 divided by 100 meters. Okay, so that's my variables all written down and converted into standard form. So now I can use these things together. If I don't convert it, I can't time hertz by centimeters, because then I get a speed that's in centimeters per second, and that's no use to anybody. Okay, so I then do c equals 18.5 times 1.2 over 100 to give me a speed of 0.22 meters per second. Okay, and if you wrote down 0.22, then you got 2 marks. If you didn't do the conversion, then you got 1 mark. so far. So 1 mark for the conversion, 1 mark for getting to this stage here. So then you've got the second part of this question. Okay, so then you want to talk about what is the standard walking speed. Okay, how fast could you reasonably do it? Okay, so if you can do 100 meters in a minute, okay, so you're going to do 60 divided by 100, which will tell you, sorry, 100 divided by 60. Okay, that's not a bad approximation, but for walking speed, the mark scheme allows any number between 0.7 to 2. So if you took a guess anywhere between 0.7 meters per second to 2 meters per second, then that gets the third mark here. And then what you've got to say is, you've got to say that this is much smaller than this. So you'd say that walking speed is much faster. And that gets you your fourth mark. So I'll just underline the bits that scored the marks. Okay. End of question 1.